Welcome to the Smart Building Center, an energy efficiency innovation space for the commercial, industrial, and institutional building operations industry. Our focus is where smart meets safety, comfort, and efficiency. And we offer state-of-the-art training and meeting spaces, educational programming, and a tool lending library with a wide variety of diagnostic and monitoring tools available to borrow for free. We also offer educational resources like this training video. So today we'll talk about some tips and tricks for using thermal cameras, also known as infrared cameras or IR cameras. And these are some of our most popular tools in the tool library. There are a wide range of models available by various manufacturers. And thermal science is a pretty in-depth science, but we're going to just give you some basic tips to get started today. So what is thermography? It's a measure of the heat given off by objects, and all objects give off some heat relative to absolute zero. Even objects we think of as very cold give off a little bit of heat. So thermal cameras map that heat signature to a visual image that we can then analyze. So infrared energy is a specific wavelength of the electromagnetic spectrum. Okay, so there are a lot of advantages and benefits to using thermography in diagnosing issues and detecting energy loss and waste. The biggest thing is that it's non-invasive. It can help save time and money because it can help measure surfaces that are hard to reach. It also requires no light, and it has a broad range of applications, especially in the building operations industry. So what are some of those applications? Well, we can use it to detect thermal envelope loss. We can look at plumbing leaks in walls. We can use it for electrical issue diagnosis, motors, plumbing, the list goes on and on. So for example, with the building envelope, we can look for thermal bridges. That is where materials conduct heat easily from the interior to the exterior. We can identify missing or defective insulation, as you can see in this image here. We can also find moisture trapped in insulation. So as you can see in this image, we've got a water leak in a wall. And you can see where the leak is because the leak is actually showing a warmer heat signature. This is because of the difference in the heat emitted between the wet insulation and the dry insulation. So for another example, we can detect roof moisture. Here we have an image that shows a leak in a roof. This is best performed at night after a sunny day and in dry conditions. As the sun shines, it heats up the roofing and the top of the insulation below it. And once the sun sets, the insulation begins to cool. However, the damp insulation cools at a much slower rate than the dry insulation. So the leaky areas are detected as warm spots when viewed at night. We can also use thermography to locate misrouted or leaking ducts in HVAC systems. Here's another image that shows a failing connector on a motor. You can see where we have this right in the center where we see a hot connector on a motor there detected by the thermal camera. We would not be able to detect that otherwise. So really good for preventive maintenance. Here we have another example. The first image is a normally operating pump motor. You can see that the thermal signature is uniform from the edges to the middle. And the other image, you can see the motor bearing is warmer than the casing. So this could be a sign of a problem. Addressed early, it may be a lot less expensive and avoid some catastrophic failure. So as we can see, thermography has a wide range of applications. Let's talk about some of the misconceptions and what thermography cannot do. For one thing, one misconception is that it's the same as night vision. It's not the same as night vision. Night vision measures wavelengths in the near infrared portion of the spectrum. It amplifies small amounts of light, and so it does require some light. Infrared thermography actually requires no light, but another common misconception is that it can see through opaque surfaces. This isn't true. What it does is it reads the heat signature at or near the surface of an object. Another misconception with thermography is that zooming, the digital zoom that is included with many thermal cameras, can actually improve resolution. This isn't true. Digital zoom makes the pixels larger, but it doesn't add pixels to the image. And another important consideration is that just because you can see something in the view of your thermal camera doesn't mean that you can measure it accurately. So we'll get into that in a little bit. So let's talk about some of the key concepts for accurate thermal images. The first is focus. Making sure your images are in focus is important. The second is making sure that you're at the proper distance for your camera and the range of your camera. Another really important concept, perhaps the most important, is the emissivity of the object you're trying to measure. So let's look a little more closely at each of these concepts. So let's talk about focus. It's important for a thermal image to be in focus for accurate diagnosis. And cameras are typically made with either an auto or fixed focus or a manual focus option. So with a fixed focus, you want to make sure that you're aware of the minimum focus distance for your specific camera. And for a manual focus, you can go ahead and focus it manually using the dial like so. So it's important to make sure before you store your image that it is in focus, because this can't be changed later. So the next concept I want to talk about is distance. And so the images that you take must be taken at the correct distance with respect to your lens and resolution of your specific camera. And so one component of this is the field of view. This is an angular measurement given in degrees. And the second component to this is the spot meter, also known as the reticle. And so this is like the little crosshairs in your image. That is where you are taking the measurement. And so you want to make sure that the target of your measurement overfills that spot meter or reticle. That way you are covering enough pixels for that measurement to be accurate. Another important component related to distance is the spot size ratio. So the spot size ratio is the ratio of the distance from the camera to the object compared to the area on the object being measured. So it's essentially the smallest object your camera can measure at any distance. For example, a spot size ratio of 24:1 means that at 24 feet away, you can measure an object up to a foot wide. The ratio can refer to any measurement, it could be feet, meters, etc., as long as both components are the same, so the distance to the area being measured. So another important concept to keep in mind is the range. And so you want to take your images in an appropriate temperature range. So some cameras only have one measurement range. You want to be aware of what your camera is capable of. And you may see on your screen an out of range symbol, which means you either need to adjust the temperature range or use a different camera. Perhaps the most important concept in thermal imaging is emissivity. So emissivity is how efficiently a material emits energy, and it's measured in a value between 0 and 1. A non-metallic surface is closer to 1, where a highly reflective metallic surface is lower, closer to 0. So what that means is that it reflects infrared energy from other sources, and that can distort your measurement and give you an inaccurate reading. So emissivity is affected by various properties, including the material itself and its emissivity value, the surface structure, whether it's smooth or rough, the geometry of the object, the angle, the temperature of the surface itself or the ambient conditions, as well as the wavelength. And so emissivity values for various materials can be found online, and what you want to do before taking an image of a specific object, you want to set your emissivity in your camera in order to get an accurate reading. So for example, I'm going to go in and click my emissivity. I can do a custom value, or I can scroll, and it has preloaded some various common surface materials that you can choose from. Now, so we have aluminum, for example, stainless, for example. I want to scroll back and talk a little bit about electrical tape. Electrical tape can be used to cover up a reflective surface so that we can get a more accurate reading. And I'll show you an example of how to do that. So I'm going to come over here to my demonstration electrical panel. And of course, as typical with any electrical panel, you have several shiny surfaces and some dull surfaces. And so for this demonstration, we're going to just zero in on this little shiny spot right here on the conduit. Now, this electrical panel has been de-energized, so there's nothing generating heat within the panel currently, and these surfaces are the same temperature. I can feel the conduit. It feels all uniform in temperature. So when we zero in on the spot we identified, and I'm just going to make sure my reticle is filled with that spot, and I can take an image, we're showing almost 85 degrees in that spot, versus right next to it where it's not shiny, we're showing 79 degrees. As I mentioned, this electrical panel is de-energized, but it had power running through it a few moments ago, which might be why it's a little warmer than room temperature. But these two areas are the exact same temperature. However, the shiny spot is appearing to emit a higher temperature. So one way we can correct for that is by making that surface dull. What we can do is we can put a piece of electrical tape on the shiny surface. That way, if you have an emissivity setting for a specific material and you're trying to read an area that is shiny versus dull, that way you can actually use the electrical tape to get a more accurate reading. So you can see that the area where I have the electrical tape is much closer to the areas around it. And now an interesting concept also to demonstrate here is the reflection in the glass behind us, which is reflecting my body temperature. Even though the glass is all a uniform temperature, it's appearing to emit a higher surface temperature because it's reflecting my body heat. So that's an example of the importance of making sure you know what materials you're measuring and the emissivity, and that you have the emissivity values set correctly in your camera. So as you can see, thermography is a very useful tool with a wide range of applications. It's also a very in-depth science, and we've really just covered some of the key concepts today to get you started. There are several training programs available that dive deeper into the concepts of thermography We recommend getting more training to really maximize the use of this tool. You can check out other videos on our YouTube channel that go a little more in depth into some of the applications. And you can also check out other resources and browse our inventory of our tool lending library by visiting our website at smartbuildingscenter.org.